Now, inequalities. One of the reasons students have trouble with inequalities is they're not always explained what the difference is between an inequality and an equality. Of course, 2x plus 4 is equal to 8, minus 4, minus 4. 2x is equal to 4, x is equal to 2. That is an inequality. An inequality is just one number that will work in the equation. If you plug 3 into this equation, it would not work. If you plugged 8 into this equation, it would not work. The only number that will work is 2. Now, if an equality means one number, then what is an inequality? An inequality is these guys. Okay? These two go together because they do not equal the number that's being represented. Excuse me. So therefore, they use an open circle on a number line. During interval notation, they'll use parentheses. And when you graph a line, it will be dotted. These two, because they have the equal sign, means that they can use the number that's being represented. So that means that you would use a closed circle on a number line. You would use brackets during interval notation. And you would use a solid line for graphing. So you have to remember this. Okay. Now, how do you use graphing or inequalities with graphing? Well, let's just take an example and use, for example, the two lines and find out where they are on the graph. So I'm going to use x plus y is equal to 7. Let's use something, well, 7's good. And 2x plus 3y is equal to 8. Okay? And I don't know why this thing is not focusing like it should. I don't know if I've done something. Maybe that's it. Okay, so I draw a big graph because this is intercepts. So I'll put 0, x-intercept, 0 is for y, y-intercept, plug in 0 for x. So I put x plus y is equal to 7. That 0 goes in for y, so x is equal to 7. And that goes there. X plus y is equal to 7. That 0 goes in for x, so that leaves y is equal to 7. And you put that 7 right there. Over here, x-intercept, 0 for y, y-intercept, 0 for x. 2x plus 3y is equal to 8. Let's make that a 6. 6. And 2x plus 3y is equal to 6. That goes there, so that whole thing goes out. 2x is equal to 6. X is equal to 3, so 3 goes there. 2x plus 3y is equal to 6, so that x goes there, knocks that out, so 3y is equal to 6, y is equal to 2. Now, you're used to doing this with equalities, but let's change this to a symbol there, and let's change this to a symbol there. Well, what does that mean? Nothing. You've already done it. There's nothing different. The only thing is you're going to be graphing these two things. So I'm going to try to draw a decent graph. I don't know how it's going to work, but I'm going to do the best I can without graph paper. Well, that's good enough. All right. So here's my 2 points here. 7, 0. 1, 2, 3, 4, 5, 6, 7. And 0, 7. 1, 2, 3, 4, 5, 6, 7. And it's a dashed line. Don't use a pen or a stylus as a straight edge because it rolls around on you. There's that line. And then this line is going to be a solid line because it's equal to 3, 0, 1, 2, 3, and 0, 2, 1, 2. Now it's going to be a solid line. And it looks like we see an intersection point right about in there. Of course, I don't have graph paper, so I have no earthly idea what it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Maybe 11 and 1, 2, 3, 4, 5, 11, -5 or something like that. I have no idea. But that's not what's important. What's important is that now you want to pick a point. So when you're dealing with inequalities on lines, first thing you do is you pick a point. I'm sorry, you draw the line. Sorry, that's 2. Draw the line, number 1. Draw the lines. And now we're going to pick a point. Pick points. Now there's 4 sections. Here's the intersection. So you've got that line that continues this way and this line that continues this way. There's 4 sections. Here's 1, there's 2, there's 3, and there's 4. There's 4 sections. These are called regions. Okay? Now it's your job to find the region that fits. How do you do? Well, you pick points. You pick points that are easy to pick and are in these regions. So I'm going to start with this region, region 1. This point right here is in region 1. What is that point? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to use 10 because it's easy to calculate. Okay, so I'm going to use 10, 0. Plug and chug. 10 plus 0 is greater than 7. True? True. Plug it in here. 2 times 10 plus 3 times 0 is greater than or equal to 6. Is 20 greater than 6? Yes. So that's your feasibility region. Feasibility region. Feasibility is where the actual solutions lie. 3. Remember, when you pick a point, if it's true, you go with that point. If it's false, then you have to find another point. Use other points. So if this one did not work, I would have to jump over here and pick 1, 2, 3, 0, 3 and plug it in. 0 plus 3 is not more than 7, so that wouldn't work. Let's go with 1, 2, 3, 4, 5. 0, -5. 0 minus 5 is -5. -5 is not greater than 7, so that wouldn't work. So this is not the feasibility region. That's not the feasibility region. Okay, let's pick a point here. No, this is 11, 12, 13, 14, 15. 15 and -8. 15 and -8. That might work there. But what about here? 15 and -8. Well, 15, that'd be 30 minus 24 is 6. So that might work. I don't know, but it's not going to work here. So we can check it, but you need to have graph paper. Okay, graph paper is a necessity. Because if you don't have graph paper, you don't know what these points are. That's 1, 2, 3, 4, 5, 6, 7, 8. Maybe it's 8. And that's 11, 12, 13, 14, 15. 15 and 8. Okay, so try 15 and 8 here. 2 times 15 plus 3 times 8 is greater than 6. Well, 2 times 15 is 30. 30, and that's going to be a negative 8. Be a negative 24. 30 minus 24 is 6. So that's a possibility. So that may be a possibility. But what about here? That's going to be, I don't forgot my 1, 2, 3, 4, 5, 6, 7, 8. Negative 8 plus 15. That's 7. 7 is not greater than 7, so that will not work. So the only region that will work is this region right here. But how do you write that? I'm sorry, something's wrong with this. How do you write that? How do you write this whole area right here? You can't say, okay, the answer is this whole area right here. Well, you can't do that. What you do is you look at the x. The x here, I'm sorry, yeah. The x here, we said, is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm saying it's 11, but it may not be. Okay, so the answer would be x is equal to 11 would take all of these, or x is greater than 11. I'm sorry, yeah. Okay. So is 11 greater than, well, you would have to put the y also. So 11 and 0. 11 is greater than 7? Yes. 11, 22 plus 0 is 22. Is 22 greater than 6? Yes. So anything greater than 11 will work. Okay. You could also use this number right here. 1, 2, 3, 4, 5, 6, 7. X is greater than 7. That's it. That's the answer. X is greater than 7 is your answer. Okay? Because you cannot use 7 right here. So you have to use 8. Will 8 work? 8 plus 0, yes. Will 9 work? Yes. Will 8 work over here? Yes. Okay? So this is your answer. So if you wrote it in interval notation, it would be 7, comma, infinity, and this would have a parenthesis on it, and since this is not equal to, this would have a parenthesis on it. So this is your answer. X such that, put that in braces, that is that builder notation, and that's your two answers to this feasibility region right here. And that's how you do inequalities. Okay, I hope that helps you a little bit.